Our topic for today is about area of regular polygons. The area of a regular polygon is expressed in the equation A equals 1/2 apothem perimeter, where A is the apothem and P is the perimeter. What is an apothem? An apothem is the length of the radius of the inscribed circle of the polygon. So, looking at all these examples here, I have here a square. You all know that a square is a regular polygon because it has equal angles and equal sides, and it is convex. The line drawn from the center of the circle to the part of the circle, on the circle, from the center to the circle is the apothem. Notice that in reference to the regular polygon, the apothem is directly perpendicular to the side of the regular polygon, connecting the center to the midpoint of the side of the regular polygon. Let's look at this equilateral triangle. An equilateral triangle is also a regular polygon because it has equal angles and equal sides. This right here is the apothem. Once again, it's the perpendicular figure from the center of your polygon to the midpoint of the other side. I have here a pentagon, and this right here is the example of my apothem. My first example is a square. We all know that a square is a regular polygon because of the sides being congruent and the angles being congruent. We also know that the area of a square is expressed in side times side, or base times height, or length times width, or let's use base times height. If I'm going to use this, the apothem here is what's given, and the apothem is 5. However, I can translate this to the other side, which will make this become a 10. And this side is also 10. And so 10 times 10 is 100 centimeters squared. That is the area of your square. I want to also show you how to use the formula using the 1/2 apothem perimeter. If I use my formula for the area of a square, which is a regular polygon, I'm going to use my 1/2 apothem perimeter. My apothem is given as 5 centimeters, and my perimeter, definitely, if I calculate, is going to become, that's 10 times 4. It's going to be 40 centimeters. I can cancel this out and simplify it into 20. And so 20 times 5 is going to give me 100. Centimeters times centimeters is centimeters squared, which ties up to my other area that we had used. Now I want you to try to solve for the area of a regular hexagon with side length of 12 feet. So based off of the formula for the area, you want the apothem and you want the perimeter. The perimeter is kind of easy to determine because each side is 12 feet. So what you're going to do for the perimeter is you're just going to go ahead and multiply 12 by 6. 12 feet by 6. So that is going to be 72 feet. Now your goal is to solve for the next component, which is the apothem. So the apothem is missing. But you know that if this is the center, you can draw triangles in each of them to determine the apothem. So the apothem is this piece, and that we need to identify the length of the apothem. So what I did with my hexagon, with my regular hexagon, is from the center, I drew the triangles that are connecting the vertices. And so I know that all of these are 60. So 60, 60, 60. This is 60. So that's 60, all of them. Because that's 60, I know that this right here is 30. If that's 30, then this is 90, and this is my 60-degree angle. Therefore, I can have some measurements given to me because I know that half of this one right here is 6. And I know that this is going to be right here, 6 square root of 3. We already discussed that on our 30, 60, 90 topic when we were there. So now this is, if this whole thing is 12, and by the way, this is now 60, but then I'm drawing my perpendicular segment from the center of your polygon. So this becomes 30, 60, 90. It's a special type of right triangle. So if the whole side is 12, then this piece right here is 6, and the altitude, or this segment right here, the apothegm, I'm sorry, is going to be 6 square root of 3. So let's go ahead and solve for the area of this regular hexagon. So area of the hexagon is going to be 1/2 apothegm 6 square root of 3. Perimeter is 72 feet. I'm going to choose what I can divide by 2, and I want to divide this by 2 because I want to be dealing with small numbers. Or maybe not. I will just divide this by 2. So I can just have 3 square root of 3 times 72. My area is going to be 216 square root of 3 feet. No, that is 1/2 apothegm perimeter. Oh, I'm sorry. This is what's missing. This is supposed to have a unit of feet as well. So that is supposed to be feet squared. For our third and final example, find the area of a regular pentagon with side length of 10. So what we're going to do is we're going to try our best to cut this into 5 equal triangles. So what I did was I had cut my pentagon into 5 equal triangles, which will be 360 degrees. So this whole thing is 360 degrees. Divided by 5 is going to give you 72 in all of them. But I need my apothegm. So because I need my apothegm, I'm going to go ahead and draw it here. That is my approximated apothegm. Therefore, this angle right here is going to be 36 degrees, and this is going to be 54 degrees. For you to find the apothegm, you need to use your trigonometric functions. So, katoa. After our trigonometric calculations and all calculations done, we found out that the length of the apothegm is 6.88 inches and the perimeter is 10 inches times 5 because this is a pentagon. And so let's go ahead and solve for the area. It's 1/2 apothegm perimeter. So area is equal to 1/2 parentheses 6.88 inches. Perimeter is 50 inches. I'm going to go ahead and cut this in half. So I will just have 25 inches. Based off of our calculations, this 6.88 times 25 is going to give us 172, and our unit is inches squared. I hope you learned about area of a regular polygon today. Good luck in all your problem solving.